5 pounds, guess my weight. To the nearest 5 pounds.
155.
Guess, not out loud, write it down. I'm sorry, I should have specified that, Tim. To the nearest 5 pounds, guess my weight. I'm not going to tell you that because that's the next data set. It just increased by 2 ounces. But I'll have to pee soon, so it'll bounce back out. Speaking of that, I got a physiological question to ask. Any phys majors in here? Anybody A&P, relatively good A&P knowledge? After class, if you have 2 minutes, I have a question I would love to know about. The counterintuitive, something that's happened in master swimming every morning. It involves water and coffee and peeing. So. Not in the pool. I have to run out of the pool in my freaking Speedo to go pee and then come back. And I'm trying to cut that down. I have a theory. Anyway, let's go back. Let's collect some data. Let's get some guesses. Let's hear them now. Just throw them out there.
175.
175. Who's below 175?
55.
55? Anybody below 155? What do we got, Rox?
145.
45? Anybody below 145?
41.
41? Can we call it 140? Just to go up to the nearest fives. 140. Okay, so we got a low. X equals Sean's weight. Thank you. This is going to be awesome, I can tell already. 140, 145, 150, 155, 160, 165. I heard a 175, right?
Yes.
Anybody 180? 190? Anybody above 175s?
185.
185. Walter, who are you?
185.
Okay, and so 185 is the max? I know I wear baggy clothes and it makes it hard to tell. That's good, this is good. I love that, I love that. Look at that, 45 pound range. It makes me happy. That's like a leg of range. Good. All right, let's get some frequencies. Let's get some frequencies. How many 140s? There were a couple of you, right? 2 of you. 2 of you 140s. 145s. 1, 2, good. This might be some nice skewed data. 150? Maybe. Ooh, I think so. 155? Oh, Serena, you were a 150. She was 150. Okay, we got a 1 there. 155s? I still think it's going to be skewed. This is awesome. 1, 2, 3. 160s? Here we go. Here comes the humps. 1, 2, 3, 4, 5. 65s? 2, 3. Oh, it's freaking awesome. 170. I should collect this historically and see what happens. I'll start today. 1, 2. 175. I do it every term. I don't keep track historically of the data that I get. 3. 180. No, and then 2 185s? Is that correct? We got Walter and we got Patrick. Great. Fantastic data. Let's look at it. This is great. This is great. This is the most varied it's ever been. So I'm freaking stoked. I am. This is great. This is great. Stacy, thank you for asking for more data. Good stuff. Yeah. What does rule weigh? Snorts are the best. They are. I'm dead serious, damn it. It's the George Carlin class clown repressed laughter. The best kind. Rest in peace, George. 2, 2, 1, 3, 5, 3, 2, 3, 0, 2.
Except that I think it was true.
And we may have to play with the window to get a decent window to look at. I'm thinking. The reason I had you go by 5s is twofold. Number one, chances are when you give your weight, you probably go to the nearest 5 pounds anyway, or nearest 10. But also it makes it easier. Oh, and it's also easier to graph it by 5s than anything else. So let's hit a little zoom stat to fix it. Okay, there's the TI's decision on the window. Freaking love it. I'm gonna finagle. I'm going to make the low 140, but the high 190. And I'm going to scale it by 5 pound increments. And you see why I'm going to 190, friends? Walter, you and Patrick are going to be out in the 185 to 190 bar because that bar needs to have a distance. So you guys, you're going to see a bar at the far end. That's going to be you two.
You can zero the Y min too, right?
Yes, as per what Danny said earlier. Yes, we can zero the Y min, and then we can hit graph. See what it looks like? That is a damn nice graph. It's a damn nice graph. I love it. I'm going to put some numbers on here so we can also refer to it.
Would you call that null shaped?
I was just about to ask you that.
So I would say so. Yeah.
Cool.
Roughly bell-shaped.
Cool. And this is that thing. I love that Nick just asked me that. He said, would I call that bell-shaped? It's not whether I would call it bell-shaped. Would you call it bell-shaped? And there's, just so you know, there's no correct answer for this. Who says yes, bell-shaped? I can totally see why. It's a pretty small data set. Chances are, if we were guessing from a normal distribution, that's probably what it looked like after 23 guesses. I would guess, yeah. So it's bell-shaped. Let's find the cutoffs for unusual based on that. Would you guys like to see the keyboard shortcuts on the TI for this?
Yes.
Now, just realize this is in at least 2 other places in your resources. Number 1, it's on the quiz that's posted last week. I think you guys got that back on Monday. In that variation quiz, in the last part of that quiz, I walked you through the button pushes for that. Also, I went back and re-uploaded videos for the PSSC questions from the last homework set, me walking through the PSSC, and I've got a TI opened up on a screen with the graph, and I walk you through it there too. So just so you know, what I'm about to do, if it goes by too quickly for any of the steps, it's in at least 2 other places where you can get back to them. It all starts with 1 of our stats though. It all starts with 1 var stats. Yeah, we got a meeting that time. That was cool. 1 var stats on L1 and L2. Boom! Aha! You guys underestimated my weight by 15 pounds almost. I'm 175.
Yes.
175. You underestimated my weight by 15 pounds. That's amazing. It's all my brick head. And funny too, I'll get 2 pounds up here.
Yeah.
Didn't wash it today either.
Yeah, this makes sense.
So, this is cool. I love this. And this always happens. My weight's always underestimated, but never by 15 pounds. Thank you all. Quite nice. Quite nice. So now, the reason you had to do this was because you had to create this and this in the TI because it needs to use those to give you the number for cutoffs. So we now have to do X bar plus and minus 2S. So what you can do is you can quit out of there, get back to your home screen. Okay, watch with me here. The vars button. Vars button.
Vars 5.
Vars 5, yes ma'am, you're with it. 2 gets you X bar. So vars 5, 2. And now X bar is on your home screen. Don't do anything yet to it. Right now, if you press enter, it'll kick out 161 point whatever the average was. But let's go ahead and add 2 S's to it right now. So plus 2, and I think it is vars 5, 3, yeah? Stacy's got it. Vars 5, yep, 3. When you press enter, it's going to tell you Heidi's critical value on the top. And there it is. 187 is the top critical value. We'll add that to the graph in a second. When I put the graph back up, we'll add that. Now here's the best part. We got to do X bar minus 2S. Watch this. Second enter. Arrow over, change the plus to a minus. How many of you knew that trick from before? The second enter trick? Yeah, like 3 of you, exactly. It's one of the most powerful tricks on a TI. And that's not saying much because they're pretty unpowerful. But that saves you so much time when you're doing edits. Let's just press enter. There's the low cutoff. There's the low cutoff. Which means, if anybody guessed below 136 pounds, that would have been too low. And if anybody guessed above 187 pounds, that would have been too high. Do we have any outliers?
No.
Do we have any outliers? 136, right?
Yep.
And this was 187? Heidi, there are your 2 standard deviations. Any outlier guesses?
No.
Wow, how can there be no outlier guesses when they're that deviant? I just gave you the answer. Because they're that deviant. The standard deviation is wickedly wide. You guys guessed wickedly. So I show my 80s here. 140 pounds up to 185? Holy Lord. So by definition, all 100% of the data is within it. But listen to what John said from before. Not 0.95 times 23 is not going to give you a whole number of outliers. So it doesn't even predict one outlier in particular, does it? It gives us a fractional outlier. And this is what I'm saying. Don't force outliers. I thought for sure these guys were going to be outliers. I thought for sure. And they almost were by 2 pounds. But whatever. By the mathematical definition, they weren't. Eh? Good stuff. Yeah, good stuff. Making sense? Now, for those of you who weren't completely convinced that it was bell-shaped, Are there outliers using the other method? Don't you dare change that box plot. Don't you dare change. Stacey, listen to me.
I'm not.
I see your thumbs on that thing, you're not texting. Are there outliers based on that box plot right there, which is a non-modified one? Ah, you can tell. Fingers. Yes, yes, IQR. 50% more. Stack. Stack. There can't be. If there were, they would be further out. And again, the reason that there aren't is due to the variability. You guys are almost uniformly variant in your guesses. I love that. Almost uniformly variant. There's definitely an average right here, which syncs up with the median. There's the 161, there's your median of 160. It's perfect. But uniformly variant otherwise. Pretty slick, huh? Pretty slick. John?
If this was a larger data set and there was 100 of us,
Yes.
and it was still within the same range, and nobody guessed 180, and it's within the, both of these definitions, could that become an outlier?
Absolutely! Because what you just described is a standard deviation shrinking. And if a standard deviation, because, right? If you said if everybody's guessing within this range and nobody's guessing 180, that means they're all guessing in here, right?
So even though it's in the middle of the graph.
Yes, but the middle of the graph, A, might change with more data.
Right.
But even if it doesn't, the standard deviation definitely will as the sample size gets larger. Because the average distance is going to go down.
Right.
Which means that 12 will become a 10. Actually, if it becomes a 10, these guys become outliers, doesn't it? If it becomes 10, it's then 20 points up from 160, which is 180, which means 185 is now outside. So yeah, for sure, great question. Another great question.
It just pushes it outside. It doesn't.
That's it. It doesn't move. It's just that the range itself is going to go like this. So there's two things that can happen. The data can get more variant, or your range can get tighter. Both of them leave. It's the old thing. How do you get volunteers? Somebody steps forward, or everybody else steps back.
So the median can never be an outlier.
Well, I've thought about this actually. I have. I've thought about this because I once read an article called A Data Set That is 44% Outliers. So 44% of the data were defined to be outliers by one of these two definitions. I forget which one it was. And I started thinking to myself, holy crap. If that's true, right, exactly, how can that be? But it's one of those crazy mathematical twist things that even though 44% of it was an outlier, the median still wasn't. But it makes me wonder, could I create some stupid data set where even the median was an outlier? My gut is saying, no, you can't do that. But then I read that, I'm like, almost everything except the median's an outlier. I don't think so. I haven't thought of one yet. My guess is no. I've also thought of things, can you have a data set where the average is bigger than Q3 or less than Q1? Because usually, you'll notice, the average and the median are pretty close. They're close-ish. Could you ever have something where the bell curve is so far down here and Q1 is so far over there? My gut is yes. It's related to your question. Can we skew the data so greatly that there's mass disagreement between the two methods? I'm guessing the answer is yes. I haven't quite thought about it enough yet. Should we take kids swim lessons? Please, Renee.
What if it is bimodal?
What if it's I was thinking unimodal. Yes, bimodal is a great answer to that. A bimodal distribution would be a perfect, simple, beautiful, elegant solution to that, which I wouldn't have even thought about because I'm thinking unimodal. Yeah, bimodal, if you make one mode slightly higher, that creates potentially the very thing we're talking about. That's good. Christine, what are you thinking?
I was going to say, when you were talking about the two humps with the giant gap and then the median,
and I stopped
if
thinking
you
about
had
it.
one like
Yep.
that, you could pull the average to either side.
You could by just weighting the data more. Listen to YouTube or not. I'm telling you. Here, let's collect one more data set I'm going to send you guys home with. And bring it back on Monday, so that way we don't totally forget what we're talking about today. Don't do the outlier homework for class on Monday. But I'm going to give you one homework assignment. Guess my height to the nearest inch. Shoes off? No, you may not. I'll turn the light on though. Whoa! I usually go barefoot, so yes, I do. Unfortunately, know that. Wait, hang on.
Okay.
Let's knock this down without ponytail.
Without ponytail.
Or dreadlocks. No, I'm not busting on dreadlocks. I got a few myself right now.
It takes 9 hours and then you don't have to brush your hair for several years.
I know.
It's ingenious.
I know, but
so weird from this angle trying to guess somebody's height. Like sitting down.
Oh, yeah, that's true, yeah, that's true, sitting down. I'm trying to remove reference, though. I don't want you to be able to, like, use your own eyes as a reference point.
Sean, can you lay down on the floor and put your heels against the wall?
No. I could, yes, I won't. I could, yes, I won't. Okay, let's collect the data so you guys have something to take home and analyze for Monday. So I'll put that up on the board behind me. Look at the rag. Stop using my hands. What do we got for guesses?
5'10".
5'10"? So what's that? Height in inches? That's 70 inches. Frequency. Okay, so I have 70. Anybody go below 5'10"?
5'8".
5'8", so that's 68.
5'9".
5'8".
5'9".
Oh, 5'9". So 68, I think, is a low ball. Okay, so 68, 69, 70. Anybody go 5'11"? 5'11". Anybody go 5'12"? 6 foot? Damn imperial system of measurement. 6'1"? That's 6'1"? 6'2"? Whoa, 6'2"s?
Yeah.
Remember, not the ponytail. 6'3"? 6'3"s? You know what I should do? Damn, it's too late now. I could correlate my height guess with your weight guess and see if there's a correlation. That would be fun. Oh well. 70, what is it, 6'3", 6'4"? Anybody go above 6'4"? Okay, there we are. Let's get some frequencies. Who guessed 5'8", which is what this is, right? 5'8", we got one of those. 5'9"? 1, 2, 3 5'9"s. 5'10"? 7. Love this. 5'11"? Did it again. 6 foot? Oh, 1, 2 6-footers. 6'1"? Gene? 6'2"? 6. Love this. This is freaking awesome. 6'3"? Got at least one. Is that you, Danny? Oh, you were 6'2". You were 6'2". You're good. We got. Good. There we go. There's data. Your job. Take that home. Take that home. Graph it. Decide what shape it is. Interesting. Besides interesting, which it is very much right now. And then decide if any of those guesses are considered outliers. I'm tempted to even think the 73 is an outlier just based on the double humps. But again, it's too small a data set to decide there should be double humps by modal. But yeah, so is Lawanda 68 too low? Is Brandon, is Brandon 75 inches too high? Or is the variation so great that they're just to be expected? I don't know the answer to this because I can't do that in my head.
Well, how tall are you?
5'11" and a half, depending what time of day you measure me. So I'm right about, where's 5'11"? Right about here. Somewhere about here.
I think it was your slender figure that made
My slender figure. The one you guys estimated was 185. My girlish figure.
So muscly. What if you were 5'8" and 185?
Then my pediatrician would say, what are you feeding him? You guys are awesome. I want some answers on Monday, yes? I promise to get this crap uploaded now that I have office hours. I apologize for not getting this stuff up earlier. Be well. We'll talk to you soon.